All right, good morning, everyone, and welcome to Nvidia NGC Jupyter Notebook Day Recommender System. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable. If you have any questions during the webcast, you can submit them through the Q&A widget. We will try to answer these throughout and at the end of the event. A copy of today's slide deck and additional help materials are available in the resource list. We encourage you to download any resources or bookmark any links that you may find useful. You can find additional answers to some common technical issues located in the help widget at the bottom of your screen. An on-demand version of the webcast will be available approximately 1 hour after the webcast and can be accessed using the same audience link that was sent to you earlier. Now I'll pass it over to Akil.
Awesome. Thanks, Kristen. Hey, everyone. Like Kristen said, my name is Akil. I'm a product marketer in the NGC team at Nvidia, and really happy to be here. And I'm really thankful for all of you for taking time from your schedule to join us today. I'm also joined by my colleague, Shakufe, who's a technical marketing engineer in the NGC team, and also the one who helped build this notebook together. So the idea today is to give you a quick overview of the NGC catalog. We hear a lot about, what is NGC? How can I leverage it for building my AI applications? Can you give me a quick overview? So I'm going to cover the quick overview here, and then from there we're going to go to the demo. The demo is detailed. It starts off, essentially how do you build a container to how do you actually run this Jupyter notebook. So it's a very sort of step-by-step process. So you'll see a good value from, if you've never done anything before with building a container, then you'll get a good idea of what it looks like, how you can easily use the container from the NGC catalog, and also the Jupyter notebook that we're going to show today. So before we get started, we always like to do this and just kind of get a pulse for, where the audience is coming from, and even if they know about NGC. And it's a great metric for us to collect and really understand how we can give more value to you as you start off on your AI and HPC journey. So with that, I'm going to poll the audience before I get started. This is a very simple question. Have you used the NGC catalog before? And we've seen a tremendous amount of data from here, and we're always using that data to improve how we reach out to end users here. So if you could take a couple of minutes here just to answer this question, I will then move on to the slides. All right, hopefully that was enough time for everyone. Let's get into it. So, I think when we see this picture or this collection of pictures, we can all sort of agree and nod our heads, and we can say, hey, AI has reached mainstream, and more importantly, it's starting to reach the tipping point. And what we mean by that is, now organizations are using AI across many use cases for their product needs, either to build better products or deliver better services or improve operational efficiencies, whatever their goals might be. Using AI for their own internal needs or even essentially building products is becoming the norm right now. I think one of the statistics that really pops out here is the fact that O'Reilly, that interviewed a lot of the organizations out there, said about 50% of them were actually putting AI into production, right? And so we could talk about tons of use cases across the gamut. I'm going to just touch on a few here. The first one is looking at better product recommendations. We interact with so many different things today via mobile phones, shopping on Amazon, looking at movies via Netflix or Hulu. Everything has a way to recommend things to us. And the idea again is that as a user, I want to know what's the best product I can pick, and I want to know what goes along with that best product. And from an enterprise standpoint, that's really value add, because then they can help the user pick the best product from their perspective. So, looking at, adding value from a product recommendation or even personalized search perspective. The next one you have is sort of like the fraud detection, right? So, financial companies are using AI to detect fraud in real time. And again, that helps add value to us as customers so that nobody else is stealing my identity. But also, in their side, they're actually saving a lot of operational costs. So it has a dual benefit, both from an enterprise and also from an end user perspective. And if you think about medical imaging, right, we're living this right now with the pandemic. And again, using AI in medical imaging really helps medical professionals understand the diagnosis, understand what's happening with someone within their body from a disease perspective, how it's spreading, what's causing it. And so really AI is accelerating that process, but it can also be used in drug discovery as well. So there's so many different use cases that you could apply for AI within healthcare itself. But to sort of think about how this whole thing comes together, right? From a if you never built AI applications before, or you're actually building AI applications, the understanding here is that there's amazing power in AI, but the idea is that AI can also be very complex and the workflows are very detailed, right? This isn't just a representation of what one workflow could look like, right? So you start with extracting the data and understanding and doing large-scale data analytics. You go into building and training and optimizing the deep learning models. Then you have to essentially amplify that model. You have to build an application around it, and then eventually you have to deploy it, right? So all these different steps you see here are not really meant to be pedantic here in the sense that each step is actually listed out. It's more about the fact that there are many different people with many different needs within this workflow, and all the needs need to be met in one form or shape or the other, right? And that really means that you have an extended timeline. And a point that I like to make here is from a DevOps perspective, if you deploy that application, then you need to constantly monitor it and you need to constantly update it. And the reason for that is, let's say you put out this awesome app and then all these different people, different users come to your platform to use that app. Well, what are they going to do? They're going to use it. They're going to generate tons of data, and that data needs to go back for you to then refine that model. So it's a cyclical process. It never ends. You're always updating, you're always refining. And again, it goes back to all these different people needing the right tools to accomplish their goal. And which is essentially why we built the NGC catalog, right? To look at all these different steps, to simplify the steps, and also to help accelerate that. And how are we doing that today? Well, we're reducing these steps firstly by providing high-performance containers, right, to help accelerate data analytics or even allow you to build your, do your deep learning training itself. We're giving you pre-trained models that allow you to get a head start in terms of what you do from an AI application perspective. Your developers can build faster because now they don't have to necessarily start from scratch. They can pull in domain-specific SDK and then wrap their application around it, and then help your DevOps to consistently deploy into production. And when you do that, and when you're able to address these steps that we've just removed, let's say as an example here, you're able to shrink that timeline. And then imagine what you can do with that extra time, like obviously do more testing, build better products, whatever that looks like for you from an enterprise perspective. But that's our goal, that's our vision, and that's how we built the NGC catalog. So I'm gonna walk through these 4 different artifacts here very quickly because I think I wanna give you a good idea of what's available in the catalog today and how it actually functions. So let's start with containers. So containers were, the catalog started off with as a container registry. And over the years, we've added more and more containers. Today, you can find more than 80 containers that span deep learning, HPC, visualization, also data analytics. So you can get a good diverse set of containers that you would need for your application or your use case. But we also want to go one step further. We just don't want this to be the wild, wild west where people can just upload a container and say, hey, come download my container. We want to control it, and that's why we want to make it ready for enterprises to use, right? So how do we do that? So all the containers that you see here are tested for CVEs, for malware, for crypto, so essentially making sure that they're secure. We also test them for reliability by testing them on different platforms. And essentially for the Nvidia AI software, there's also an optional enterprise support. But again, making sure that enterprises can get full value and that their users don't have to find different sources and untrustworthy sources, if you will, at the end of the day to build their applications. But from a developer perspective, and most of you are developers on this call here, what about the performance, right? It's all about performance at the end of the day. Time to solution is really important. So one thing is scalable, right? How scalable are these containers? So we test them on single GPU. We ensure that they can scale to multi-GPU and also to multi-node training if you need them. More importantly, you've already spent a massive amount of money on your infrastructure. Again, the idea is that you spend a lot of money on your capital expenditure. How do you actually extract more performance from that system? So again, this is essentially where our engineering team are on a monthly basis updating the libraries and dependencies and routines within the container to give you the best bang for the buck. So from one version to the other, our goal is to give you that next best performing container that you can pull. And so again, you can extract better performance from the same system. And finally, we want to make sure that these are deployable anywhere, right? So we support Docker, obviously, but you can also run them on Creo, Containerd, and if you're from the HPC segment, then Singularity is the norm there. You can also run our containers in Singularity runtime. Again, you can run them on bare metal, VMs, and also in Kubernetes, but also run them on-prem within your own data center, but go beyond the walls of the data center to the hybrid, essentially the cloud, or even to the edge as well. So we want to make sure that they can work everywhere as well. The next one I want to talk about are pre-trained models. And again, this is the key part because that's the focal point of the demo that you'll see later today. And, again, as I said before, over the years, we've started to build up the repository of the pre-trained models that you see here. So again, the NGC catalog offers a wide set of pre-trained models. So essentially for popular AI tasks. So if you're in computer vision, you can find models for Resonant 50 or SSD. If you're in conversational AI, then you'll find models for Jasper, for ASR, BERT for NLU, etc. But if you're in the recommender space, then you can find models for wide and deep and also DLRM and many more. So the idea is to curate these sets of the models that you can actually use for your various use cases. One key thing about these models is that you can apply transfer learning. And what that means is that you can take a model that was built, let's say, for detecting faces, and you can apply your own data and then change that model so that you can detect faces with masks or with no masks on. And that's a really cool feature because then it reduces the amount of time you take for training. And more importantly, as you come to NGC and look at all these different models, you'll see that most of these models actually carry what we call credentials. And so the credentials idea here is that it lets you know how we train the model, what the accuracy of the model is, what was the batch size, and where we got the data set from. So really kind of giving you an upfront view of what the model looks like, what you can use it for, and maybe more importantly, what the limitations of the model could be when you start using it for your own use case. And let's say you didn't want to start with these pre-trained models from the get-go, and you wanted to kind of build your own or recreate what we do within Nvidia, then we're also giving you resources, which are code snippets. So again, samples are available and recipes are available, so you can follow them step by step. So again, containers, pre-trained models, kind of the backbone, the building blocks, if you will, for your AI journey. I want to go into the SDK bit a little bit. And again, the SDKs here are span across many domains. We talked about the building blocks of containers and pre-trained models. The SDKs we carry within the NGC catalog, are in medical imaging, genomics, and drug discovery with Clara, Isaac for robotics, Merlin for recommender systems. We have Drive for self-driving cars, Metropolis for smart cities and retail. Our goal, our vision is to address that end-to-end pipeline. And you'll see more and more SDKs being populated over time as we build out this catalog. But we address this because we want to make sure that as a developer, you're able to kind of grab that and build your application around it. Three key things that I want you to take away. The first one, I mentioned this, which is the transfer learning toolkit, essentially a domain adaptability, right? You take that and you add your own data to it and you can tweak it to fit your use case. I mentioned to you that the face mask detection example, and we've actually built an example around that, and we can share that link with you. But the idea was that we took a model that detected faces, and we applied transfer learning to then detect masks on people, if there were masks or not, which is a great way because today everybody, is starting to use that type of an application for their own uses. But don't just think within my example that I'm giving, but you can apply domain adaptability here and really significantly reduce that development time. The second piece I want to talk about is TensorRT, which essentially allows you to optimize your deep learning model for low latency and high throughput. And what it does is essentially understands your application, and it optimizes for a number of competing constraints, such as accuracy, throughput, response time, and really optimizes that application for that GPU itself. So a great tool here where you can essentially put in your model and then get completely optimize it for inferencing. And the last one I want to leave you with here on the frameworks is Triton. And Triton is an inference server which provides a inference service via HTTP or gRPC endpoint. So it allows remote clients to request inferencing, essentially for any model that is managed by the server. And what's cool about this is that it can support multiple frameworks, right? So TensorFlow, PyTorch, and Onyx, and it does so with real-time and also with batch and inferencing queries. So very, very powerful when it comes to inferencing your deep learning applications. And finally, the fourth asset here that I want to, or artifact I want to talk about, are the Helm charts that are available. And what we've done with our approach here, and to enable consistent deployment across platforms, we're bringing a cloud-native approach across Kubernetes and Helm. So as you may be aware, Kubernetes orchestrates and manages containerized workflows. So for example, if you have thousands of worker nodes and you want to be deploying your application on those, then you can use Kubernetes to be able to do that. One cool example is it allows you to auto-scale. So if you see a massive demand in the user type, then you can spin up pods, or you can spin down pods based on the demand that you see. Another feature is self-healing, so you can actually spin up another node if you need to, if one of the nodes goes down for any reason whatsoever. So again, it really streamlines massive scale deployment. Helm, on the other hand, actually communicates with Kubernetes and allows you to define, install, and upgrade even on the most complex Kubernetes application. All right, so this way you can easily deploy your containers that you built directly from the NGC catalog. The one example I want to cite here are the GPU operator, which essentially allows you to surface the GPUs. It allows you to install all the necessary drivers, the monitoring tools, and device plugins. It really makes it easy for you to deploy your applications. And what's cool about that is that it allows IT to have a single golden image there. And we're building up this NGC Helm registry constantly, so you'll see support for Nvidia AI software, for our industry application frameworks as well, and also for our partner applications. And so, this is something that, we want to address all the needs of all the different people that are part of the entire workflow, not just the data scientist or the developer, but also at the end where, these applications are actually deployed into production. So with that, I want to sort of set the stage for what the demo is about. And, today's demo is broadly going to give you a taste for the Jupyter Notebook that was built to get you started with recommendation systems. Obviously, from an end user perspective, and that's the lens that I usually have, is that, it touches, recommendation system touches in many different ways, right? Personalized merchandising. So if I buy Tide, well, I need Bounty, right? Something like that. If you buy beer, you need chips. So essentially understanding what I'm looking for, what I've done in the past, and really kind of helping me get to the best products that I would need. Personalized content is a great one. Books, movies, and music is a great example where content is personalized for you. Personalized search, better search results can also be pulled from that. What I want to sort of address here is that, like I said before, the notebook is a sample one. And again, what you'll see is that this model allows you to, or this notebook predicts the rate of a movie for a user and recommends those movies. So very simple sort of like approach that we've taken, and it's just meant to get you started. But we also recognize that building this end-to-end recommendation system is complex. And so what Nvidia is doing is working really hard to simplify that process and democratize that process. And for that, we built what we call the Nvidia Merlin framework, essentially for large-scale deep learning recommender systems. So that is the next level up. And if you're really interested in learning more about that, we have the link at the very end of this presentation. This demo is just about getting started, getting your feet in the water. If you're already in this area and you wanted to explore more about the end-to-end framework, I highly recommend that you look up Nvidia Merlin and learn more about that. So with that, I will move over to the demo and get it going.
Thanks, Akil. In this demo, I go through the steps that cover the training and testing a VAE model from Nvidia NGC that is used for recommendation system. This demo covers these steps: cloning the resource from Nvidia NGC, building the container, running the container in interactive mode, download the dataset inside the container, run the Jupyter Lab inside the container, upload Jupyter Notebook in Jupyter Lab, train and test the model by running the notebook cell. The variational autoencoder is an optimized implementation of the architecture first described in variational autoencoders for collaborating filtering and can be used for recommendation tests. By using variational autoencoder for collaborating filtering, you can quickly train a recommendation model. The required input data consists of pairs of user and item IDs for each interaction between a user and an item. With a trained model, you can run inference to predict what item a new user is most likely to interact with. The dataset. The dataset that we use for training this model is a movie rating dataset. The trained model predicts the rate of a movie for a user based on previous rates of the user for other movies. To get this model up and running, your system needs to have some components. First of all, you need to have Nvidia Docker up and running, and you need to have access to Nvidia GPU-based system that can be on your local system or on the cloud. I'm running this demo on a Google Cloud instance. You can use any other cloud instance too. You need to have the TensorFlow NGC containers in your system too. In the first step, we need to build a container from the resource that we have here. You can find the resources related to this model in NGC resources with the name of VA for TensorFlow. You can download the resources manually from the top right part of the page here, or you can use the wget command to clone the resources. When you clone the resources, you need to build a container from the resources using docker build command. The next step is running the container in interactive mode. Let's go to the command line and run this command to see the result. I made a directory called VAE, and I moved to the directory, and I downloaded the resources in this directory. I used the wget command to clone the resources in the directory. And the resources is in a zip format, so I use the unzip command to unzip the resources. Then I use the Docker file here to build a container from this resource. So use the Docker build, and I tag it with the name of VAE. You can use any name that you want for your container. The next step is running this container in interactive mode. So I use the docker run -it as I want to have it in interactive mode. And the runtime that we use here is Nvidia. And we need to mount a folder called data for this container. And we need to define the port for this container, because we need to run the JupyterLab inside container, and we have access to JupyterLab on the port that we define here. The name of container, any name that you choose, and we can run the container now. It takes a couple seconds and you have access to your container. The workspace here called code. So it's your main workspace. Let's go back to NGC. The next step is downloading the dataset. We use the Movie Lens 20M dataset. The VAE model was VACF model was trained on the Movie Lens 20M dataset. Movie Lens 20M is a movie rating dataset. It includes 20 million ratings and 465,000 tag applications, applies to 27,000 movies by 138,000 users. The goal of this model is to predict the rate of a new movie for a user considering the previous setup movie and rate of the user. If you do not have this dataset downloaded, you need to run these 4 commands. Made a directory called ml20m, made another directory inside this directory called extracted. Use the wget commands to download the dataset inside extracted and unzip this dataset. If you already have the dataset downloaded and unzipped, you can run these 2 commands to have the dataset inside your container. First, exit the current running container. Then rerun the container by mounting the dataset location. And so here, you need to put the path to the ML20M folder datasets here. Let's go to the command line and run this part. So the dataset need to be downloaded in the extracted folder. Let's go to the data folder. So we have the folder here called ML20M. I already downloaded dataset, so I show you how does it look like. I go to this folder, and you can see there are 2 folders here. One of them called extracted. I go to the extracted, and you can see the dataset that I already downloaded and unzipped here. So let's go back to the main workspace. Here you can see the main workspace, the code. So I will go to this workspace. Now I want to run the Jupyter Lab inside the container. Now I have the container up and running and I have the data set. I will continue the rest of the demo inside the Jupyter Lab. So use the Jupyter notebook, and the IP that we define here is 0000, and the port is the port that we defined inside the container is 8888. This command produces a link to a Jupyter Lab in a couple of seconds. So we have access to Jupyter Lab by running that link. So click on one of these links, and for the host name, if you're on local system, it will be localhost. But here I'm running the demo on the Google Cloud instance, so I need to replace the host name with the external IP of this instance. Now I have access to the Jupyter Lab. In the next step, I need to upload the notebook inside this Jupyter Lab. You can download the notebook from here manually, or you can use the wget commands to download the notebook. I already downloaded the notebook, so I upload it here. The name of notebook is VAE model. So let's start running the cells of this notebook. The first step is preparing the dataset. After you downloading the dataset instructor folder, you need to go back to the main workspace and run the prepare dataset here to divide the dataset to train, validation, and test datasets. Let's run this cell. So it shows that the data pairing works fine. And in this model, the metrics of accuracy is recall. In information retrieval, recall is a fraction of the relevant documents that are successfully retrieved. For example, for a text search on a set of documents, recall is the number of the correct result divided by the number of the result that should have been returned. For this model, the performance of the model is the number of the correct predict rate over the correct rates. The model predicts the rate of a movie for a user, and we have all the correct rates for a movie. So we find the recall by dividing the correct predicted model by whole correct rates. So true positive divided by true positive is plus false negative. The next step is training the model. The training can be started by running the main script with the train argument. The resulting checkpoints contain the train model weights are then stored in the directory specified by the checkpoints dir directory. Here you can see that it's a script that we want to use, and this argument shows that we want to use it for training. And we define the checkpoints directory, so after training we have the weights of the model in this directory. Let's start the training. When you run the training command, you can see the details of training process in each epoch. And after each 50 epochs, you can see the inference of the model. And you can see the recall of the model inference. Recall shows the performance of this model, that is the percentage of the correct prediction rate over the all correct rates. So training takes a few minutes, and then you can see the result of training. So the training is done, and you can see the result of each epoch. And after 50 epochs, you have the recall, you have an inference. So let's go to the testing step. The model can be loaded and tested using this command. So you can see we define the test argument, and we have the checkpoints in directory. So we use the weights of the model that have been saved in the checkpoints to test this model. And we need to run this command to test the model. In the pre-processing step, the ML20M dataset was divided to train, test, and validation datasets. In this step, we use the test dataset and the train model to test the performance of the model. And as we said before, the recall here shows the accuracy of the model prediction. It shows how much is the probability that the model predicts the rate of a movie for a user correctly. You can see some warning here. It's not important. There is no error. And this model was trained using some default hyperparameters and a small data set for 400 epochs. You can try larger data sets, more training epochs, and different hyperparameters to enhance the model performance. So these are the most important command line parameters. The data directory, you can change the data directory if you want to use another data set or larger data set. And checkpoint directory shows where the checkpoints will be stored. And there are also multiple parameters controlling the various hyperparameters of the training process. such as learning rate, batch size, and so on. If you want to see the full list of available options, use this command, python main.py-help. It shows all available options. For example, if you want to train the model, you need to use --train. If you want to test the model, you need to use --test. If you want to use it for inference benchmarking, use this. If you want to change the number of epochs, you need to define these parameters. And if you want to put it on the default hyperparameters, you don't need to define any of these parts. You just need to define if you want train, test, or inference the model. So you can, in summary, you have two options. You can use the default hyperparameters and just change the train, test, or inference option, or you can change all the default hyperparameters or change some of the default hyperparameters.
Awesome. Thanks, Shikufe, for the demo, and hopefully that was pretty valuable for everyone to kind of see the start to finish process. Lots of cool resources that I want to leave you with. She's written a technical blog that essentially talks through all the steps she went through in a little bit more detail, obviously, because we can't cover everything in a demo situation. But feel free to capture this link here, screenshot it, and we'll also send in our follow-up email so you can use this. It's already available and live on our NVIDIA developer blog site. Along with that, you can also download the notebook that she just presented today. So that's also available on the NGC catalog. And before the demo, I mentioned that about NVIDIA Merlin, and if you really wanted to, kind of go up and understand the end-to-end deep learning recommendation systems and how you can leverage that, then I highly recommend that you go to NVIDIA Merlin's site and learn more about it, because that will take you to the next level compared to how we're just showing you how to get started with the simple sample notebook here today. And a couple things I want to point out is that I always get this question: is NVIDIA NGC, to use NVIDIA NGC catalog, do I have to pay for it? The answer is no. We are building a community accessible portal so people can come in and get their HPC AI containers, or essentially models and SDKs as well for their AI needs. We asked for a sign up, but you don't have to sign up to be able to use these artifacts. It's completely optional. On top of that, you don't have to. It's completely free. So I want to make sure that the audience on the call here get that across, because I get that a lot, even talking to a lot of different people. The next is a question that we'd like to hear from you. We want to build more of these notebooks, and we want to sort of create and curate a collection of these notebooks over time. And what we want to make sure is that we can hear from you on this one. And so if you have ideas, examples that you want us to post on the NGC catalog or make it available for you to get started, we'd love to hear from you. So I'll give you about a minute or so to just kind of type in your answers here. All right, I will move to my last slide here, which is about our upcoming GTC conference, which is going to be on the 12th through the 16th of April. So please mark your calendars. There's going to be amazing content all across different industries, different use cases, from AI, HPC, healthcare, game developing, and more. Our CEO keynote is on the 12th of April, and it's available for everyone. And so please tune into that one. And if you want to sign up and register, which is free, please go to nvidia.com/GTC, and you should be able to get all the details you need to sign up. With that, I want to move to some of the questions that were being posed, and Shikufe has been answering them. I think this is a very good question, and I'll read it aloud here. What key benefits does using Jupyter Notebook for training / testing deliver over command line interface? Is it just friendlier, or are there other benefits? Shikufe, you live this world. Do you mind answering this question for us, please?
They can run all these commands on command line, but I think it's easier and for new users to see the process on a notebook. They can try it on the command line, and both of them works. It depends on the user which way is easier for them.
Awesome, thank you. I want to go back to some of the questions that were being answered, and I think for the people on the call it might be beneficial. So I think the first one is this available only through the Google Cloud? I think there's two parts to this question. I'm going to try to answer that. The first one is the catalog itself is cloud hosted, and it's available for pretty much anyone to use. So you can do that. The second one is perhaps my interpretation of this question is, is it only available on Google? No, if you can run the containers, you can run the models essentially on your own in-house infrastructure, let's say on-prem, or you can also run it on the cloud instances. We have what we call VMIs, or virtual machine images, that are already integrated into the cloud service providers, and that allows you to pull these containers directly into your cloud instance. So, if you're running on AWS or GCP or Azure, some of obviously the big guys, we are integrated with them. So it's making it really easy for you to kind of do the workload portability, go from the cloud or back to on-prem or what have you. This question is interesting. Is this the main advantage for data scientists? I get a bunch of pre-trained models easily. Is that right? Absolutely. I think that is what we're trying to do. Right, and that's the mission of NGC, is that we want to make sure that what we learn within Nvidia and all the research that we're doing, we want to bring that to the community, and we want to be able to curate the catalog with awesome models. So our goal is to just really make sure that you can come to NGC and say, oh yeah, I want to build an app that recognizes cats versus dogs. How easy is it? Well, here's a pre-trained model that can do image classification. Let me just run that and train it. So you're not kind of going back in time and building that model from scratch, because we've already done it for you. So that's our goal, essentially, to help add value to you. So you're spending less time kind of building the model, more time hopefully building the application. This question here, for a particular usage realm, how would one choose between the available containers in NGC? Yeah, so I think if you go to the NGC website, you'll see that we've classified different containers for different use cases. The easiest way to sort of understand that is to just type in the search query, say deep learning or inference or HPC, and you'll see the filters work for you, and then you'll see that for an HPC search query, all the HPC containers come into play. And then you can start to say, okay, I want to use this application to visualize my massive data set, which is, for example, ParaView, or I want to do deep learning, then TensorFlow or PyTorch or MXNet are some of the containers that are available. So you can do a quick search, and you can actually look through the catalog that tells you what use cases you can use this container for. So Shikufe, this question, if you can help answer, what framework can you use an API for? They're asking Juniper, but this is the first time I'm hearing it. But maybe you can help answer that, Shikufe. Or is it? I wonder if it's Jupyter. Maybe the person who asked can just clarify if it's Juniper or Jupyter. Shikufe, can you talk about what framework you use for this training?
I think it's Jupyter Notebook. I use Anaconda.
Okay, thank you. This is a very interesting question. How do I change the model architecture?
They can change the hyperparameters of the model and retrain the whole model. So we had some arguments, and if you change all this argument, you can change the hyperparameters. But for changing whole models, It's not an option inside the scripts.
Got it. So if you have to change the whole architecture, you're basically starting from scratch. And maybe I can add that. So if you wanted to start from scratch, I would definitely recommend checking out resources on the catalog. And what they are essentially are code snippets. So you can start from point zero and rebuild the model by the recipe that we provide. So rather than using the model that Shakufe has built, a kind of pre-trained model, if you want to start from scratch, then you can use the resources there. So pretty useful artifact that we have on the catalog. I think those are the extent of the questions that I see here. So pretty excited that we're going to end early here. I'm going to give you some time back for in your day. Kristen, do you want to just wrap us up here?
Yeah, I can do that. So we want to thank everyone for attending the webinar. We hope you guys found it interesting and informative. And then just as a reminder, the on-demand version of the webcast and all the resources will be sent out in approximately 1 hour. So that's it. Thank you, everyone, and have a great rest of your day.
Thank you, everyone. Bye now.